Good morning. Myself Prabharan J, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is concept of state under state variable in linear control systems. Yeah, let us discuss. In classical control systems, we normally study transfer functions, but in modern control system, we need a better way to describe complex systems. That is where the concept of state variables become important. In this presentation, we will connect design thinking concept with state variable analysis to understand the topic in a simple way. First, let us discuss the first pillar of design thinking called empathize. In design thinking, empathize means understanding user needs, problems, and current situations before giving solutions. Similarly, in control systems, we first identify the current state of the systems. A system variable represents the present condition of the system. For example, position, velocity, current, or voltage can act as state variables. These variables help us understand how the system behaves at a particular instant of time. Now, let us move to the second pillar called define. In design thinking, define means identifying the exact problem clearly. In state variable analysis, we define something called the state space. State space means collection of all possible states of the systems. We also identify minimum number of variables required to completely describe the system. This helps engineers analyze the system behavior more accurately. Next is the third pillar called ideate. In design thinking, which means ideate means generating many possible solutions. Similarly, in control systems, we study how the system changes from one state to another. These changes are called state transition. Different control input produce different trajectories in the state space. Using this approach, the engineers can compare different system responses and select the best control strategy. Now let us discuss the fourth pillar called prototype. Prototype means creating a model before implementing the real system. In control systems, we develop mathematical model using differential equations. These models help us simulate system behavior under different conditions. Simulation is very important because it reduces risk, save cost, and improves accuracy before practical implementation. Now, let us do one small classroom activity. The puzzle question you can see on your screen. Your job is you have to find the value of the question mark position. Now, let us move to the fifth pillar called test. Testing means evaluating system performance and improving it continuously. In control system, feedback plays a major role. Feedback helps the system correct errors and achieve the desired output. This iterative process improve the system stability and performance. This slide explains the connection between design thinking and control systems. There are three important steps: measure, compare, and accumulate. First, we observe the current state. Next, we compare it with the desired target. Finally, we continuously adjust the system until the goal is achieved. This is the basic principle behind feedback control systems. Here we see how the state variable concepts are used in different field. Design thinking is mainly used in behavioral and social science. State variable analysis is used in engineering systems, but both approach focus on understanding the current condition and improving future performance. This shows that control principles are useful across multiple disciplines. This slide explains the importance of combining design thinking with state variable analysis. Design thinking helps us understand problems, state variable analysis helps us engineer the solution. Together, they provide a systematic and measurable approach to solving real-world problems. Now we are in the assessment quiz. Let I check your understanding through this assessment quiz. Here we have two assessment quiz. First one is what is the primary purpose of a state variable in control systems? First option is to reduce hardware cost, and second option option is to fully describe the system condition at any given time, and the third one is to increase oscillation, and fourth one is to replace feedback control. And which one is correct? The option B is correct. They fully describe the system condition at any given time. And the second question is the collection of all possible states of a system is called option A is transfer function, option B is frequency response, option C is space, option D is root locus. Which one is correct? Option C is correct. That is state space. Let us summarize today's discussion. We studied empathize, define, ideate, prototype, and test. These five pillars directly led to the life cycle of state variable analysis. We also learned how feedback and iterative improvement help achieve predictable and controllable system performance. Thus, state variable analysis is a powerful tool in modern control engineering. Mm, I hope this session helped you understand the concept of state. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.